Hello student, I hope you are doing good. In today's session, I'll be covering one such paper of JEE Main session 2. So I'll be covering the 4th April paper, that too of morning shift. So we'll be covering all the questions of physics. So the first question that came in your examination is this one. When an object is placed 40 centimeter away from the spherical mirror, an image of a magnification half is produced. To obtain the image with magnification of 1/3, the object is to be moved. So these are the four options. So it says spherical mirror produces a magnification of half, which is nothing but f by f minus u. U is already given to you, u1 is given to you as minus 40. When object is placed at a distance of 40 centimeter, the magnification is half. So the magnification formula is f by f minus u, and u1 first it is placed at a distance of minus 40, minus it will be plus 40. So from this you can easily calculate the focal length. So f comes out to be 40 centimeter. Next, to obtain an image with magnification 1/3, the object should be moved. So again you need to find out first u2. Magnification is 1/3, which is f by f minus u2. So 1/3 is equal to f. F is already calculated as 40. From this you can easily calculate u2. And from this u2 comes out to be 40 minus u2 is equal to 120, and u2 comes out to be minus 80 centimeter. That means initially u1 it was placed at a distance of 40 centimeter. Now the new object distance comes out to be 80 centimeter. That means it will move away from its initial position, and it will move a distance of 40 centimeter. Okay, initially it was at 40 centimeter. Finally, when magnification is 1/3, it is 80 centimeter. So it will be moving away a distance of 40 centimeter. The answer would be fourth one. Okay, 40 centimeter away from the mirror. Next, two infinite identical charged sheets and a charged spherical body of charge density rho are arranged as shown in figure. Then the correct relationship between the electric field at A, B, C and D point is. So we have been given these sheets. Electric field because of this sheet will be sigma by 2 epsilon naught, don't you think? Sigma by 2 epsilon naught. For this also it would be sigma by 2 epsilon naught. For this sheet it would be sigma by 2 epsilon naught on either side of the sheet. Okay. So if I'll calculate the electric field at particular point C, so it would be because of this sheet, these two sheet, plus because of this spherical shell. Okay, so this would be electric field at C would be twice sigma by 2 epsilon naught, because for this it would be outward, for this electric field would be outward, for this also it would be outward, plus electric field because of spherical shell. Okay, which is, let the charge on this spherical shell be q, kq by r square. This distance, let this distance be x, so this would be x square. Okay. Likewise, electric field at this particular point D would be, because of sheet it would be outward, again because of this sheet would be outward, so this would be 2 sigma by 2 epsilon naught, plus because of this, let this distance be y from this center of this shell, so electric field at D would be 2 sigma by epsilon naught and plus kq by y square. Okay, since these two parameters are almost identical, so the only difference through which you can make out the net electric field is because of x and y. Okay, since it is at a very near distance, that means y is very near. So electric field because of this shell at this particular point would be more. Okay. So this is, so kq by r square. So this distance is less. Okay. Less distance, that means electric field would, because of this would be high, so this would be higher than this. That means electric field at D is greater than electric field at C. Okay. Next. That means electric field at C is not equal to electric field at D. What about electric field at A and B? Electric field, because of these sheets at B, would gonna cancel out each other. Okay, so the only at A also, because of these two sheets, the electric field will gonna cancel out each other, because it is for this it is towards right, for this it will be towards left, for this left. Okay, now only the difference is because of the electric field, because of this spherical shell. Because of this spherical shell, the electric field at A would be higher as compared to electric field at B, because it is at larger distance from the shell. That means electric field at A is greater than electric field at B. So which option is correct? So electric field at A is greater than electric field at B, and EC is not equal to D. So that means first option is the correct option that you must get. Next, consider the Bohr model of hydrogen-like atom. The ratio of the radius of fifth orbit of the electron in lithium 2 plus helium plus is. So for the nth radius in the Bohr atom, it is given by relationship R is equal to R nth is equal to R naught n square by Z, where Z is a atomic number and n is the nth orbit. Okay, so this is a relationship. For hydrogen, n is here fifth for hydrogen, for lithium like atom, divided by fifth orbit of helium plus, and it is of lithium plus. So we can easily write it as R naught is the first orbit, radius R naught 5 whole square for lithium, and for lithium the atomic number is, it is 3. Okay, for helium it would be R naught 5 raised to power 2 divided by helium, which is 2. This 2 will gonna cancel out, you will get 2 ratio 3. Okay, so the second option that we are getting is the correct option that we must get. Next, Boolean expression y is already given to you as this, can be realized with which of the following configuration. As you can see, this is an OR symbol, so it would have 1 or 2 input. At least you need a 2 input OR gate. Okay, so you will be needing 2 input, 2 input OR gate. At least you will be needing 2 input OR gate. Here also you will be needing 2 input OR gate. Okay, here in the third option there is 3 input OR gate, which is not true, because these two would be only 2 input which will be fed into OR gate. Okay, so here A, B and C will be coming from here, and A naught, C naught will be coming from here. So finally we will get this expression, the final answer. So that means you will be needing 2 input OR gate first. Okay, so which option is correct? Only A and B option is only correct, that you must get. Okay. Next, consider a sound wave traveling in the ideal gas of helium, methane and carbon dioxide. All gases have the same ratio of pressure by density, where P is the pressure and rho is the density, the ratio of the speed of sound through gas. So you need to find out the ratio of the speed of sound in that particular gas. The velocity is already given to you as gamma P by rho. This is the relationship of speed of sound in gas, where gamma is the specific heat, it is a ratio of molar heat capacity at constant pressure to the constant volume. Okay, Cp by Cv. For this, it is already for these three gases, P by rho ratio is constant. So that means V is only directly proportional to under root times of gamma. Okay, so V of helium ratio V of CH4 ratio V of CO2 would be under root of gamma helium ratio under root of gamma CH4 ratio under root of gamma CO2. Okay, so gamma helium is for helium, so it is, since it is a monoatomic gas, so it would be equivalent to 5 by 3. CH4 is a polyatomic gas, so it would be gamma for it is 4 by 3. For CO2 it would have 3 translational mode, and it would have 2 rotational mode. So that means degree of freedom would be 5. So this would be equal to 5, 7 by 5. Okay, so the final expression that we are getting is the second option is the correct option that we are getting. Next, the mean free path and the average speed of an oxygen molecule at 300 Kelvin and 1 atm are 3 into 10 to the power minus 7 meter and 600 meter per second respectively. Find the frequency of its oscillation. Frequency is 1 upon time period of oscillation, and time period is nothing but V average by gamma, where gamma is, this is nothing, this term lambda is nothing but it is taken as mean free path. So V average is already given to you as 600, and this is 3 into 10 to the power minus 7. So 3 2s are, so 2 into 10 to the power 7, 8, 9. So this is the expression that we are getting. So fourth option is the correct option that you must get. Next, it is a statement with question. Assertion says, in photoelectric effect, on increasing the intensity of incident light, the stopping potential increases. So that means what is the relationship between photoelectric in photoelectric effect, the intensity versus stopping potential? There is no such relationship between intensity and stopping potential. So that means this statement is wrong. Next, increasing the intensity of light increases the rate of photoelectron emitted. This is true. By increasing the intensity, the more number of electron will come out of the in photoelectric effect, it will come out of the metal surface. That means it is true, provided the frequency of incident rate is greater than threshold frequency. That means if it is greater than, the incident ray frequency is greater than threshold, so that means this phenomena will gonna happen. So that means this statement is correct. So fourth option would be the correct option. A is false and R is reason is true. Next, in a Young's double slit experiment, the slits are separated by 0.2 mm. If the slit separation is increased to 0.4 mm, the percentage change in the fringe width will be. This is also one such question which is quite easy. Fringe width beta is given to you as lambda capital D by small d, where small d is the distance between the slits. So rest for, you are only increasing this small d from 0.2 to 0.4 mm. Rest other parameter remains constant. So that means beta, this fringe width is then inversely proportional to d. Okay. So initial fringe width is lambda capital D by 0.2 mm. Beta 2 would be equal to lambda d by 0.4 mm. So this is nothing but lambda d by half of 0.2 mm. So that means this is half of beta 1. That means your fringe width will decrease. It will become half. So the change would be 50%. Don't you think? From initial value it becomes half. So finally it becomes half. So that means the change is 50%. Okay. So the percentage change in the width is 50%. Next, A small mirror of small m, mass m is suspended by a massless thread of length L. So I have been given this small mirror suspended by a thread of length L having mass m. Then the small angle through which the thread will be deflected when short pulse of laser of energy E falls normal onto the mirror. C is speed of light in vacuum and G is acceleration due to gravity. Okay. When a small laser pulse is incident and it strikes back, so it will move through a certain distance. Okay, just like this, it will move through a certain distance that you need to find out. So initially this mirror was at rest, so we're gonna find out the initial energy of this, the energy of this incident laser light would be E, was E. Okay, where C is speed of light and G is acceleration due to gravity. So VE that we already know is given by H, C by lambda, and lambda is given by, lambda is H by P. H will gonna cancel out. E is C times of P. Okay. Energy is C times of P. So E by C is your initial momentum. It will come with the momentum of E by C. It will be strike back with the momentum of E by C. So we'll be conserving the momentum. Initially, the momentum in this particular direction, I'll take it as positive. So this direction would automatically be negative. Change in momentum would be equal to, so initial momentum was, pulse was coming and the momentum of this mirror was 0 and pulse was coming in this particular direction, so it would have momentum, initial momentum of this. Finally, the final momentum of this laser light is minus E by C, and the momentum of this would be, let this momentum would be P dash. Okay, so the final momentum after which it will gonna move is P dash, which is, it will go over there, so 2E by C. So this is the momentum of mirror, initial momentum of mirror. Next, now we know the momentum with which it will go up. Let the angle through which it will move is theta, and this is L length, so this would be cos component, so this would be L cos theta. So this height would be equivalent to height through which it has moved is L, this total L minus L cos theta. Okay, so the energy possessed by this mirror would be equal to, energy is P square by P dash P square by 2m. So this is the total energy possessed by it in the terms of energy, in the terms of momentum it is P square by 2m. So this entire energy will be consumed in increasing the potential energy of this mirror. So it will be m into g into h, height through which it will move up is L minus L cos theta. I'll gonna take it as common, 1 minus cos theta. Okay, and P dash whole square comes out to be 2 to the 4 E square by C square into 2m. Okay, so this is the expression that we are getting. So this is equal to m into g into L. 1 minus cos theta is nothing but 2 into sine square theta by 2. It can easily be written as this. From this, we're gonna solve the value for theta. When angle is very small, sine theta is equal to, it would be equivalent to theta. So this whole term would be equivalent to theta square by 4. Okay, so 4 E square by C square 2m. M will come over here, so it will be m square GL. So this must be equal to 2 into theta square by 4. Okay, this will be 2 to the 4 and 2 will gonna cancel out. So theta comes out to be, theta will go over there. So it would be under root 4 E square by C square m square GL is equal to theta. So from this, it comes out to be 2E by Cm under root GL. So the final expression that we are getting is the first option. Okay. Next, which of the following are the correct expression for torque acting on a body? So you have been given these expressions. Torque is L cross R cross L, where L is angular momentum. So obviously this is not the true expression because it should be equal to R cross F, force into perpendicular distance, yeah, R cross F. So this is the correct expression. Torque is also given to you in rotation. It is equal to I alpha. Torque is also, it can also be written as R dp by dt is nothing but change in momentum per unit time is nothing but force R cross F. So this is also true. This is also true. And this expression is also true because eventually you're going to differentiate, you will get this expression also. So this is also true. The only wrong expression is the first option. That means third option would be the correct option. On the B, C, D, E is the only option that is correct. Okay. Next. If L and P represent the angular momentum and the linear momentum respectively of a particle of mass small m having position vector, this are the direction of forces. First of all, you have to just draw the expression for it. Suppose this is a position vector, okay, and it makes an angle theta which is omega t at any particular time. So this would be equivalent to, its R is nothing but A cos, so the magnitude of this R vector is, this would be A cos theta, theta is omega t, okay, along the x-axis, and along the y-axis it would be A sine omega t, okay. So the position vector R is sum of these two vector. So this vector is represented as, suppose an object is there, it would have two position vectors along the along I cap, along x-axis it would be A cos omega t, along y it would be A sin omega t. So that means this is an expression for SHM. It means along the x-axis this particle is oscillating just like this. So at any particular point it would have a restoring force towards its mean position. For this particle, if it is moving away, it would also be for this particle along the x-axis. This is also an equation for SHM. So this force would also be along this particular direction. So that means net force would be in this particular direction, which is in the direction of opposite to this R. Okay, this position vector. So that means the answer would be opposite to the direction of this position vector. This would be the net force which is acting, and that means that force is always directed towards the center. Okay, I hope this question is clear to you. So now अब हम 12th question देखते हैं. देखो, it says two small sphere ball of mass 10 gram each with charge minus 2 microcoulomb and plus 2 microcoulomb are attached to the two end of a very light rod of length 20 centimeter. The arrangement is now placed near an infinite or non-conducting charge sheet with uniform charge density, which is already given to you, such that the length of the rod makes an angle 30 degree with the electric field generated by sheet. Net torque acting on the rod is, देखो तो एक इनफाइनाइट शीट है और उस पर एक रॉड के चारों तरफ आपने टू एंड्स पे आपने क्या किया है, यू हैव प्लेस्ड 2 microcoulomb and plus 2 microcoulomb and minus 2 microcoulomb charge, and these rod it has a length of L which is nothing but 20 centimeter. Charge density of this sheet is sigma. So electric field would be outward, and this electric field would be sigma by 2 epsilon naught, that we already know. So this setup will act like a dipole having dipole moment P, which is given by Q times of this length L. Okay, and you need to find out the torque. Torque acting is that we already know, it is given by PE sin theta. The angle between this rod and this electric field is theta, which is already given to you as 30 degree. Okay, so we can easily calculate torque, and torque is given by P. P is nothing but Q times of L, and E is electric field, and sin theta. Okay, charge is nothing but 2 into 10 raised to the power minus 6 coulomb. Length is of a rod is 20 by 100, which is in meter, and electric field would be sigma by 2 epsilon naught. Sigma charge density is also given to you as 100 into 10 to the power minus 6 micro coulomb per meter square, sigma by 2 epsilon naught. Okay, into sine 30, which is half. So from this we can easily put the value of epsilon naught and find out the value of torque in Newton meter. So it comes out to be 1.12 Newton meter after solving this equation. Okay, so this is how you're gonna solve it. We'll be moving to the next question. Next question says, two simple pendulum having length L1 and L2 with negligible string mass undergoes angular displacement theta 1 and theta 2 from their mean position. So the angular acceleration of both the pendulum are same, then which expression is correct? We already know that if you have given a pendulum and it is given a small displacement theta, the weight will make it to come towards its mean position. The component of the weight which make it to come in towards its mean position is mg sine theta, because this angle is theta, so this would be the cos component and this would be the sine component. So mg sine theta will make it to come towards its mean position. So the torque acting on it would be equivalent to force into perpendicular distance. Force is mg sine theta and this perpendicular distance is length of this rod. So this must be equal to I alpha. Okay, in rotation this must be equal to I into alpha. For small angle, sin theta must be equal to theta, so this is mgl theta, and moment of inertia of this would be ml square into alpha. This is how you can easily calculate. L will gonna cancel out, so alpha comes out to be g theta by L. Okay, it says if the angular acceleration of both the pendulum are same, so that means angular acceleration of both the pendulums are same. So we're gonna calculate the first angular acceleration is g theta 1 by L1. Okay, length of the rod. This must be equal to g theta 2 by L2. Both would have the same angular acceleration, so theta 1 L2 must be equal to theta 2 L1. So this is the expression that we are getting. So that means fourth option is the correct option that we are getting. Okay, next. Current passing through the wire as a function of time is given to you as this. So the charge that will flow from the wire from t is equal to 1 to 2 seconds. So we already know that dq, the charge flow is called I dt. Okay, from this we're gonna put the value of I, which is nothing but 2 by 100 t plus 1 by 100 into dt. Okay, so you need to find out, we're gonna integrate both the side. So this is how you're gonna find out 2 by 100 integration of t dt plus 1 upon 100 integration of dt. So you need to find out the charge that flows from t is equal to 1 to t is equal to 2 seconds. So time comes from 1 to 2 seconds. So we're gonna have this, and integration of this would be t square by 2. 2 we're gonna cancel out. This is, the time is from 1 to 2 seconds. 1 upon 100 integration of dt is t 1 to 2. From this we're gonna put the upper limit minus lower limit. So this is 2 to the 4 minus 1, which is 3. So 3 by 100 plus this would be 2 minus 1. So this is 1 by 100. So eventually you'll get 4 by 100, which is nothing but 1 by 25. So 1 by 25 or 4 by 100 is nothing but 0.04 coulomb. So the fourth option is the correct option that you must get. Next, You have been given an assertion and reason. Assertion says the kinetic energy needed to project a body of mass small m from the Earth's surface to infinity is half mgr, where r is the radius of Earth. So first of all, we're going to see the kinetic energy needed to put the object to an infinite distance from the surface of Earth is given to you as. First of all, we need to find out the escape velocity. Escape velocity is given by root 2gm by r, where m is the mass of this Earth, r is radius of the Earth. So this is the escape velocity. So the kinetic energy would be equivalent to half m v square, which is 2gm by r. If I'm gonna multiply with r or r, so here gm by r square is nothing but acceleration due to gravity. 2 will gonna cancel out. You will get m small g into r. So this is the small mgr is the energy needed so that it will overcome its gravity and go to the infinite place. So it is not half mgr, it is mgr. Okay, so this statement is wrong. So reason says the maximum potential energy of the body is 0 when it is projected to an infinite from the surface of Earth. It is true because as we move from infinite, at infinite the potential energy is 0. As we move closer, it will be increasing in the negative term. Okay, so it will be more negative. So that means at infinite the potential energy is maximum. Okay, so the second option is true, A is false, and reason is true. Next, a body of mass small m is suspended by two string making an angle theta 1 and theta 2 with a horizontal ceiling with tension T1 T2. T1 T2 having the relation this, the angle theta 1 theta 2 are, and what is the value of T2. So first of all, what is given to you is this setup in which the angle made by the tension T1 is theta 1 with the horizontal and the tension T2 is theta 2 with the horizontal. Okay, it will be balancing the weight mg. Okay, so you'll have to divide this T1 component into two components and again T2 into two components, horizontal and vertical. So this angle is theta 1, so this would also be theta 1. So this component would be T1 cos theta 1 and this would be theta 2. So this would be T2 cos theta 2. So these two will gonna balance each other, and the sine component of T1, which is T1 sine theta 1 plus T2 sine theta 2 will gonna balance its weight. These two components will gonna balance its weight. So these two will gonna cancel out each other at equilibrium. So T1 cos theta 1 must be equal to T2 cos theta 2. T1 is root 3 times of T2. Theta 2, T2, T2 will gonna cancel out. Cos theta 1 by cos theta 2 comes out to be 1 by root 3. What we can do is we can easily put the value of theta 1 and theta 2 from this expression, and we can see whether at which angle it satisfies this relationship. First of all, at theta 1, if we will take theta 1 as 30 degrees, so cos theta 1, this would be cos 30 would be root 3 by 2 and cos theta 2 would be 60, which is half. 2 will gonna cancel out. It is not coming out to be 1 by root 3, it is coming out to be root 3. So this expression is wrong. Second, if both are 45 degrees, so that means 1 by root 2 or 1 by root 2. From this expression, it comes out cos theta 1 by cos theta 2 comes out to be 1, which is not true. So it has to be 1 by root 3. So this is also wrong. Moving on to the next, the third option. If theta 1 is 60 degree, so that means cos 60 is half and cos 30 is root 3 by 2. 2 will gonna cancel out from this. We get it as 1 by root 3. So that means third option would be the correct option in which it satisfies the relationship. Along this also it doesn't satisfy. The fourth option is also not true because cos theta 1 by cos theta 2 must be equal to 1 by root 3. So the only third option is the correct option that you must get, and it satisfies the relation. Next, an alternating current is given to you just like this. The RMS value and the frequency is. First of all, we already know that frequency, this is omega t. Omega comes out to be 100 pi which is 2 pi into frequency. Pi we're going to cancel out. Frequency comes out to be 50 hertz. So that means either this option is correct or either this option is correct. Next, RMS value is nothing but I peak value divided by root 2. So peak value is nothing but 100 by root 2. This is your I naught peak value divided by root 2. So RMS value comes out to be 100. So that means third option is the correct option that you must get. Next, two liquid A and B have theta A and theta B as the contact angle in the capillary tube, which is given by relation K is equal to cos theta A by cos theta 2. Identify the correct relation. Dekho. First of all, K is given to you as cos theta A by cos theta B. Okay, K is, we're gonna check one by one. K is negative when the liquid A has concave meniscus. Remember, when it is have concave meniscus, that means this, if it is concave meniscus, that means this theta is less than 90 degree. If it is convex meniscus, so this angle is greater than 90 degree. When angle is less than 90 degree, so the cos theta would be positive. When this have convex meniscus, this theta is greater than 90, so this cos theta would have negative value. What do you think? Cos greater than 90, less than 180 is always negative. In the second quadrant, cos is always negative. In the first quadrant, cos is always positive. So we're going to check one by one. If liquid A has concave meniscus, that means liquid A has concave meniscus. This is concave and this is convex. Okay, so that means this term would be positive, and liquid B has convex meniscus. That means this term would be negative. In this case, it is positive, it is negative. So that means positive by negative, again we can get negative value. So that means this can be true. This can be true. For the second option, K is 0. If K is 0, for A, liquid A has convex meniscus. If liquid A has convex meniscus, that means this would be negative. And liquid B has concave meniscus, then this would be positive. That means in this particular case, if it is positive and it is negative value, so this can't be 0. You will get certain negative value. Okay, so this option is wrong. K is negative when liquid A and B has convex meniscus. If both liquid has convex meniscus, that means its value is negative, its value is also negative. So that means you cannot get negative value. So that means negative will going to cancel out, you will get positive value. So that means this is also wrong. K is negative when liquid A and B has both concave meniscus. Again, if they both have concave meniscus, so its value would be positive. So K would also be positive. So that means this is also wrong. So only option is correct is first. Next, an electromagnetic system, the quantity represented by the ratio of electric flux and magnetic flux having dimension this. So what is the value of Q and R? Electric flux is given by E dot A, electric field multiplied by dot product of electric field and area vector. Again, magnetic flux would be B dot A, where B is a magnetic field. Okay, A will gonna cancel out. It should have the dimension of E by B. So this is nothing but C, because C would have dimension of E naught by B naught. Okay, so that means the expression E by B would have the dimension of speed of light, which is L t minus 1. So you'll get m0 L1 t minus 1. So this is the expression that we are getting. From this, P comes out to be 0, Q comes out to be 1, and R comes out to be minus 1, and S comes out to be 0. Okay, A raised to power 0. Okay, so Q1 and R1. So which option is correct? The second, Q1 R minus 1. Next, in an expression with a closed organ pipe, it is filled with water by 1/5 of its volume. The frequency of the fundamental node will change by. Suppose that means you have been given a closed organ pipe. Initially, let its length be L. So the fundamental mode would be given by this relationship. We already know that lambda by 4, this must be equal to the length of this tube, closed tube. So lambda comes out to be 4L, and the frequency, initial frequency Fi is speed of sound divided by this wavelength, which is 4 into L. Okay, so this was the initial fundamental frequency. If it is filled by 1/5, if it is filled by 1/5 of L, so the only portion which is left is 4/5 of L, in which you'll get a wave, okay, sound wave. In this, let the wavelength is let it be lambda dash. So this lambda dash wavelength must be equal to 4 by 5 times of L. Okay, lambda by 4. This must be equal to, because this will produce a fundamental mode, so lambda dash by 4 must be equal to this. So lambda dash comes out to be 16 by 5 L. Okay, now the final frequency comes out to be speed of light remains, speed of sound will remain same in air. So V by lambda dash is 16 by 5 L. Okay, 16 by 5 L. So this is the final frequency that we are getting. So that means this frequency is higher. So we can easily calculate the change in frequency. F final minus F initial divided by F final into 100. So we will get the percentage increase or percentage increase in the frequency. So final F comes out to be 5 V by 16 L minus 4 minus V by 4L divided by V by 4L. V by L will gonna cancel out. I'll gonna divide the numerator and denominator with 4. So you'll get here 16. Here it comes out to be 4. So 5 minus 4, which is 1 by 16. The upper expression comes out to be 1 by 16. Here lower, it is 1 by 4. So 4 will go up. We're gonna multiply it with hundreds in order to get the percentage increase decrease. So 4 4 16, 4 25. So percentage increase comes out to be 25%. Okay. Next, so in the capacitor circuit shown, each having capacitance 16 microfarad are connected as shown in the figure. The capacitance between A and B is, what would be the capacitance between A and B? In the expression, we already know that these are connected through wires, so this would have same potential A. This B would have same potential at this point, and at this point also, because if it is connected through wire, so they would have same potential. So across A and B we have one capacitor, second, third and fourth. That means all these are in parallel combination. In parallel combination, the effective capacitance would be 4 times of C, the initial capacitance of each capacitor, 4C. So this is, and the capacitance of each would be 16 microfarad, so it comes out to be 64 microfarad. So the value of this is 64 microfarad. So the answer would be 64. Next, so the conducting wire ABCDE with each arm 10 centimeter in length is placed in the magnetic field of this perpendicular to the plane. When conductor is pulled towards the right with a constant speed of 10 centimeter per second. Induced EMF between the point A and E is in millivoltage. So that means you have been given this setup, and this wire setup is moving towards the right. So you need to find out the EMF induced across these two ends. For these two rods, these two rods won't participate in the conduction, because this wire is moving towards the right. The angle between V and this length of the rod would be 0 degrees. So these two rods won't participate. These two portions won't participate in induced EMF. Only these two would participate in it. And the effective length of this is along this particular direction would be this. This would be the effective length. Okay. Suppose this is your L length, which is 10 centimeter. This is also L, which is 10 centimeter, and this is 90 degree. So that means this is 45 and this is 45 and this would be 90. And it also makes a right angle triangle, and these two would be 45. So that means L, L. So this comes out to be L root 2. Okay. So the effective length because of these two would be along the direction, along the velocity vector would be L root 3. Okay. So the induced EMF across the terminals would be BL effective into V. Okay. B is 1 by root 2. L effective is L root 2. L is nothing but 10 by 100. In meter it would be 1 by 100. L root 2 into what is velocity with which it is moving, it is 10 centimeter per second. Okay, centimeter we have converted into meter. Root 2 will gonna cancel out. Root 2 will gonna cancel out. This 100 will gonna cancel out. You will get 1 by 100 volt, which is nothing but 10 millivolt. So the expression that we are getting is 10. Next, distance between the object and its image is 30 centimeter when magnification is minus 1 by 3. The focal length of the mirror used is x by 4 centimeter. What is the value of this x? So that means I'm gonna draw a diagram. Suppose you have been given this mirror. Focal length of this mirror, the magnification is minus 1/3. That means it is a concave mirror. You'll get magnification only when it is between when the object is beyond C. So you'll get a magnification in which the image is between C and F. Okay. So the distance between them is 30 centimeter. This is your image. Okay. I'll take this as V distance. Now initially from this magnification is 1/3 minus 1/3, and the magnification is minus V by U, that we already know, minus V by U. V is minus V because this length I have taken it as V, and U comes out to be 30 plus V. 30 plus V. So this is the distance and it has to be negative. So minus will gonna cancel out. This minus will gonna cancel out. 30 plus V comes out to be 3V. So 30 is 2V and V comes out to be 15 centimeter. Okay. So that means this length is 15 centimeter. So V is minus 15 centimeter and object is minus 45 centimeter. Those final expression that we are getting is this. From this we can easily calculate the focal length. So 1 upon F is equal to 1 upon V plus 1 upon U. V comes out to be minus 15 and U comes out to be minus 45. Okay. And focal length again it would be negative because since it is a concave mirror, so it would be 1 upon F. F is nothing but x by 4. It has to be negative. So minus we're gonna cancel out. 4 by x comes out to be, so this is 45. This would be 3 plus 1, which is 4. It will gonna cancel out. So x comes out to be 45. Okay. So the final answer that we are getting is 45. Next, 2 slab with each cross section of different material 1 and 2 with each side L and thickness D1 and D2 such that D2 is twice of D1 and D2 is twice of D1. Considering the lower edge of these slabs are fixed to the floor, we apply each shearing force on the narrow face. We apply equal shearing force on the narrow face. The angle of deformation theta 2 is twice of theta 1. So if the shear modulus of first is this, the shear modulus of second material is this, so what is the value of x? So that means you have been given a square plate and only narrow So you have been given a square plate just like this. Okay, the length of this square plate is L, and the thickness of first plate is theta 1, and you are applying a force, narrow force, so you will get a deformities, and this angle is theta 1. Okay, you will get deformities and this angle is theta 2 because of this shear force. Okay, similarly you will get another sheet which again have the same square side, but its thickness is d2, and again you are applying the same shearing force. So what would be the deformities theta 2 angle that will be you will be getting. Okay, from this we can easily calculate shear modulus is given to you as 4 into 10 raised to power 9. We're going to calculate the shear modulus of this is nothing but force per unit area. This upper area is d1 into L. This area, force per unit area. This is how you will calculate the shear modulus, shear stress by shear strain. Shear strain is theta 1. Okay, so this expression is comes out to be this. Next, for second one, x into 10 raised to power 9 is nothing but force per unit area. This area is d2 into L, and this shear modulus shear strain is theta 2. From this we already know, it is known that force per unit this d2 is twice of d1, so we're gonna put it as twice of d1 L. Theta 2 is twice of theta 1, theta 1, so it comes out to be f by 1 by 4 times of d1 L theta 1. Okay, so this is nothing but this value is nothing but 4 into 10 raised to power 9. Okay, so 4 into 10 raised to power 9 divided by 4. So x into 10 raised to power 9 comes out to be 4 into 10 raised to power 9 by 4. 4 will gonna cancel out. 10 raised to power 9, 10 raised to power 9 will cancel out. X comes out to be 1. So the final answer that we are getting is 1. Okay. Next, a circular ring and a solid sphere having same radius rolls down and on an inclined plane from rest without slipping. The ratio of their velocities when reached at the bottom of the plane is already given to you. In this particular question, the mass is not given to you. Only it has been said that the circular ring and this solid sphere would have same radius. I'm gonna take mass of these two would be same, otherwise you won't be able to solve it. Okay, so this is the expression which is not given in the question, so I'm gonna take it as same, then we would be able to solve it. Okay, if these two would be placed on an inclined plane, the acceleration of down the inclined plane is given to you as g sine theta by 1 by I by mr square. I is moment of inertia of this body. Moment of inertia of the first ring would be g sine theta divided by 1 by ring. For ring it is mr square divided by mr square. Okay, circular ring it is mr square. So mr square will gonna cancel out. It comes out to be g sine theta by 2. Okay, so this is acceleration of ring, which is g sine theta by 2. Now we're going to calculate the acceleration down the inclined plane for this solid sphere, which is g sine theta divided by 1 plus, for it is 2 by 5 mr square. Solid sphere moment of inertia is 2 by 5 mr square. Mr square will going to cancel out, so you'll get 5. This expression comes out to be 7 by 5. So 5 will gonna go up, so 5 g sine theta by 7. Okay, so the acceleration of solid sphere is 5 by 7 g sine theta. Okay, Now both would have to travel a distance L. L is the length of the inclined plane. It has to reach down. Initially both would have initial velocity as 0. Okay, so you can easily calculate the v square minus u from the relationship v square minus u square is equal to 2a L. So from v it comes out to be root 2a L. So final velocity should be in the ratio of this root 2a L. So now we're going to place the value velocity of ring is equal to root divided by velocity of solid sphere. It should be in under root 2. Acceleration of this is g sine theta by 2 into L divided by 2. A acceleration of this is 5 by 7 g sine theta into L. Okay. So 2 will gonna cancel out. G sine theta L, G sine theta will gonna cancel out. So it comes out to be, this would be 2 sine theta, 2 5 by 7 G sine theta L, and G sine theta will gonna cancel out. The expression that we are getting is under root 7 by, this is already given to you as root 7 by 2 into 5, which is root x by 5. So x comes out to be 7 by 2. So this is how you are getting the answer. So that means there is some parameter which is not given in the question. By taking these two parameters as same, the mass same, this is how you're gonna solve the question. Okay, I hope all the question is known to you and you are able to grasp all the questions. With this, I'm gonna end up this session.